Welcome back. In these videos, we're going to be walking through a number of loan modeling examples. So you guys saw this some earlier in the semester when we were developing some basic modeling skills, but we're going to revisit loan schedules and we're going to look at a few advanced features both in modeling and how we think about valuing loans. So to start out, we just need to build a basic mortgage schedule, right? Basically the mortgage payment schedule over a number of periods. So we're going to start out in our model. We're going to have 20 years. Notice that that is an input, so we're going to make this 20 a dynamic feature. Annual interest rate is going to be 4%. To keep things simple today, we're just going to assume that's an APR. So to get the monthly rate, we're just going to have to divide by 12. And then our principal balance is going to be $200,000. So the first place we're going to start is let's calculate the required payment we need. You could use the annuity formula to rearrange things. It's a little bit tougher to go look that up and if you don't necessarily remember it. So instead, let's just use the payment function. If you recall, we're going to put in our rate first. Importantly, make sure you divide that thing by 12 to take it to a monthly. Again, we're assuming that 4% is an APR. Our second argument is going to be the number of periods, 20 years, but again, multiply by 12 to get that to months. And then finally, recall we need to put a negative sign out in front of our principal balance. That way we see our payments in positive terms. So in this case, for a 20-year loan on $200,000 with a 4% interest rate, you have to pay about $1,200 a month on that. All right, so that's the basic answer of how much do you have to pay, but let's actually see how that works in the schedule and how the different balances evolve over time. So we're going to start out and we're going to model this dynamically so it doesn't just have to be a 20-year loan. All right, so how long should we allow the loan to go for? Well, 30-year loans are very common in the US. 50-year loans have been introduced more recently, so let's just add enough flexibility that we could do a 50-year loan in here if we wanted to. So the first thing I'm going to do is just get a series of 600 numbers, right? So 12 months times 50 years, we get that 600 months. We have a spilled formula there. We can say got it to recognize that we know what this spilled formula is. And so that gives our months from 1 all the way down to 600. All right, so we got a big model built. Our beginning principal, well, that's going to be equal to our principal balance. It's a lot. Our interest charge, so this is going to be whatever your beginning balance is times your interest rate. So our interest rate, make sure we lock it and divide by 12 to make that monthly. Our payment we already calculated, so let's just reference it over here. And then finally, our ending principal is the beginning balance plus any interest we owe, right? That increases how much we owe, minus how much we paid, our payment, and that gives us our ending principal. So now if we want to make this model drag down fully, we can link our beginning principal in the second period, second month, to the ending principal from the prior month. Our interest charge payment and ending principal are calculated the same way. Now we can select all 4 cells, and I'm just going to double click out here on the right, and now it drags all the way down. So let's see what it looks like when we do that. So we keep going down. If we go down here to about 240 months, notice that we pay off the loan, but according to this, we keep paying the loan, right? The way we've built our formulas is we didn't know to stop. So essentially, you kept paying the bank $1,200 or so a month, and what happens is you start getting a really negative balance, all right? In reality, this is handled, with a mortgage servicer. They're going to stop withdrawing money from your bank account once you've paid off the loan, so this shouldn't happen. But we also don't want this to show up in our model, right? We don't want to look sloppy in the sense that we're showing, oh, look, you're going to have a negative $837,000 balance at the end of 50 years, all right? So to account for that, we can actually build some more kind of flexibility into our model. So we're going to do that by first thinking about the months over here. So how many months do we want? So first I'm going to copy this and just paste values so we get rid of that sequence formula. We don't really need this sequence to be dynamic. And now we're going to think, all right, how many months do I need? Well, if my term is 20 years, then I'm going to need 20 times 12 or 240 months of rows keeping track of the balance. So if that's the case, then once we get past 240, we don't really need to show those months anymore. So I'm going to write a formula here that says if the previous month is less than 20, the number of periods, times 12, oops, I got an extra parentheses in there. So if it's less than 240, then go ahead and take the previous month and add 1. However, However, as soon as it gets to be equal to 240, well, we don't want to see those months anymore. And so a nice trick here is to just use two double quotation marks with nothing in between them. So it's just going to show a blank cell as a result. So if we hit enter, we see we get the number 2. Makes sense because 1 is less than 240. But now when we drag that down, right, double click that down, and let's jump down here to row 240, or month 240, and we see that it is the last month we see. There are still formulas down here below it, right? But they're all giving blank cells back. So visually it works very well for us. It also gets the right number as far as the number of months we want to see. Okay, so the question now is, how do we stop all this other text from showing up? So our strategy here is going to be to use the isNumber function. And actually, before I do that, let me show you why this is so important that we get these cells to be blank rather than having values. And part of the issue is we want to be able to show how much total payments our borrower is going to make and the total interest paid. So let's go ahead and calculate those right now. So if we just sum, and keep in mind we want to sum this whole column to allow this model to be dynamic. So if we sum the whole thing, we see that they pay $727,000. That seems a little high. And total interest payments of negative $313,000. That seems a little low. Again, we know this is because we have those extra lines that aren't really going to happen. We just need to clear those out so they're blank and they don't affect these sums. So again, the way we're going to do this is with the isNumber function in combination with if. So what isNumber does is, let's just type it out here. isNumber is either going to return you true or false. So in this case, it is true that cell E4 is a number. If instead I drag this over here to D4, now that's false. All right, so if there's a number in that cell, it's true, otherwise it's false. So we can use this to drive our if statement. For example, we only want to show a principal balance here if the month we are in is a number. All right, so we're going to say if E4 is a number, then give me the principal balance that I want, which is last period's ending balance. Otherwise, give me a blank cell. So let's take that and let's copy that down, and then we'll zip down here and see what happens. Well, now we've got good, we've done it well for column F. We're no longer showing principal balances, right? But now we have a value error, all right? And that's throwing something off. What's going on here? Well, now we're trying to multiply a blank cell times an interest rate. So that's not going to work. So let's actually go apply that same strategy to each of our other calculations. So I'm going to come into here and I'm going to actually copy the first part of this formula. And now at the start of each of these cells, we can put our if statement in there. That way, as long as we have a number in E4, we'll calculate the value. Otherwise, we're not going to. And we can go ahead and put this in each of our cells. So this does take a little bit of manual work, but it's really going to pretty our model up nicely and make it much more functional and dynamic. All right, so we've done that for those 3 cells. We can now take all 3, copy it down. We can actually copy these up as well. So we might as well copy those up. Our first cell, we don't really need to change this F3 because all it's doing is referencing that starting principal balance. And we're always going to have that starting principal balance, even if it's a 1-month loan. All right, so let's go back down to the month 20 and see what we see. Now we see a nice result, right? We have a 0 ending balance over here in column I, and we no longer show loan amounts afterwards. All right, but let's see if it's working dynamically, right? This is the idea, is we're driving towards a dynamic model. So let's instead change our number of years to 2 years. Now we see we actually got a 2-year loan that stops after those 2 years. Now you might have noticed that down here in the bottom right corner, we still have a 0 ending balance, but now it's red. So what's going on there? Well, when we build these models, we actually in Excel, the calculation doesn't exactly give you a 0. All right, let's actually zoom in here. We're going to zoom in. And after I zoomed in a number of digits, you see this thing is really close to 0. So we'll keep going a little bit further. And we finally got to some small numbers out there. All right, so what's happening again is just through calculation errors and just rounding essentially within the numerical methods of Excel and of computer programs. It's not exactly 0. It's really, really close to 0. It just happens to be on the negative side, which is why it shows up as red. So if your 0 at the end shows up as red, not a big deal. It's going to, for all practical intents and purposes, it is equal to 0.